Hi guys, in this video we're going to be learning how to calculate the area of a triangle. Now in order to do this, it's a good idea to already know how to calculate the area of a rectangle. There's already a video on how to do that, so if you haven't watched that yet, please go back and watch that first before you proceed with this one. If you have watched that, however, you should know already that the area of a shape is the amount of space inside that shape, and that it's measured in square units. So if we're assuming that each one of these boxes is a centimetre long, then the whole box is a square centimetre. If each box was a metre, it would be a square metre. If each box was a kilometre, it would be a square kilometre. So we can have squares of any unit of distance. Now, we should already know how to work out the area of a rectangle. So I've drawn a rectangle on the board here, and we should know that the area of a rectangle is just the base times the height. So for this rectangle, the base is 5 centimetres and the height is 4 centimetres, which means that inside the shape is just 4 times 5, which is 20 centimetres squared. Now that's rectangles. The problem is today we're not dealing with rectangles, we're dealing with triangles. But we can use this knowledge to actually help us figure out what the area of a triangle is, which is what we're going to do now. So I've now drawn a triangle with exactly the same base and height as that last rectangle. So it's 5 centimetres along the base and 4 centimetres high. Now if we imagine, or if we try to visualise what it used to look like as a rectangle, we should start to realise something. If we bring this up to the full dimensions of a rectangle, we should realise that actually this triangle is quite simply half of what it used to be as a rectangle. Therefore, if the area of a rectangle is the base times the height, the area of a triangle is the base times the height half, or divided by 2. So using that then, the area of this one should be 5 times 4, but then divided by 2. So 5 times 4 is 20, divided by 2, and what we should have in total then is 10 centimetres squared. So the total area on the inside of this triangle is simply half what it would have been if it was a rectangle. So if it was a rectangle, it'd be 4 times 5, which is 20. In reality, it's just 4 times 5 half, divided by 2, which is only 10. Now, this holds true for every triangle in the world. So we have here another triangle. It is 8 centimetres along the base, and its height from bottom to top is 2 centimetres. So following this then, what we should have is 8 times 2 divided by 2, which is 16, divided by 2, which is 8 centimetres squared. So as long as we know the base of the shape from edge to edge and the height from bottom to top, we can work out the total area of any triangle. Okay, so now we're going to look at one or two examples that can sometimes be a little bit more challenging for a couple of reasons. So we've got this triangle here, and we've been given 3 of the sides here. So we've been given this side, and this side here. Now this means we're going to have to do a little bit of thinking to work out which one actually counts as the base and which one counts as the height. Now when the triangle's at this angle, it's quite obvious. We should be able to see that the base here would be 6 and the height would be here, which is 3. So the area then would be 6 times 3 divided by 2, which is 18 divided by 2, which is 9 square centimetres. However, what happens if I rotate this triangle this way round? All of a sudden, it looks like our base is 6.7 here, and our height, I don't know, might be 3, might be 6. It's kind of hard to tell. Well, the answer is that no matter what, our base and our height are going to stay 3 and 6, or 6 and 3. If we remember that triangles are just half rectangles, it should be clear why. So let's imagine that this stays as a rectangle here. This is going to stay as a rectangle. What we would have is we would have another line coming down here to complement this line here. So there would be a mirror image of the 3 here, and then there'd be a mirror image of the 6 here. Now we can see that this 6.7 refers to this diagonal line here, which is neither the base nor the height of the rectangle. So it should now be clear, no matter what, that the base would still be 6 and the height would still be 3. So there's our base, there's our height. It's just that the triangle is at a different angle to what it was a minute ago. So bear in mind, triangles can appear at different angles, different orientation, but you should still be able to work out which one is the base, which one is the height, and use that to find your answer by timesing them together and then halving it. Cheers, guys!